This is a review and then also developing these sine theta plus theta and cosine 2 theta problems. Let's start with down here at number 4. This brings up some good discussions here. Arc cosine of 1/2. If you look at the unit circle and cosine, the point x comma y, which was the cosine, x or y? X, right? So it says the x's are 1/2. This is the ratio. We're looking for an angle. So let's talk about that. Cosine of theta equals 1/2. So you put in an angle and you get a ratio. So what arc or inverse cosine of something equals something? Okay. If it's the inverse, that means that instead of looking at the angle again, we're going to take the undoing of the ratio and we're going to find the angle. What do you call it when the x and y's are reversed? What's that called? What kind of function is that? Inverse, right? And these are definitely inverse functions, cosine and cosine inverse or arc cosine. So here's what I want you to think about from here on out with this chapter. When you see arc or inverse cosine, what you want to remember is that the ratio is what goes in there next to arc and inverse, ratio. It's not going to be a degree. It's going to be a ratio. And so if that's what the ratio is, we're going to be looking for an angle. All right. So x is 1/2. So it looks like this is the x is 1/2. If you look on your unit circle, pi over 3, and this is going to be 5 pi over 3. Looks like those are your two answers between 0 and 2 pi, and that's a skill I want you to have, is to find those two between 0 and 2 pi, and you'll see why I want you to do that in a little bit. Then, if you look at the answers, you're going to see only pi over 3 as an answer. And the reason for that is that remember when we did that $5 trick yesterday? And I said I'd give you $5 if you got beyond 200. Well, for cosine, it's only between 0 and 180. Never get a negative, never get bigger than 180. So the only answer that fits in that inverse cosine to make it a function is pi over 3. So here's what I want you to see. Pi over 3 is the answer, the correct answer, if you're using your calculator. Between 0 and 2 pi, I like these two answers. Great. Okay, then let's look at number 5 here. 5, arc sine of -4. Here's the sine curve. How high did it get to? 1. How low did it get to? -1. Did it ever get down to -4? No. So what's this answer? No answer. Or undefined, that's fine. It just doesn't exist. Try it in your calculator. Inverse sine of -4. It'll say error, right? Then let's go up to the top here. When we take the cosine of the arctangent of 4/5, what we're doing is we're taking, there you go again, there's your ratio, but what we're doing is we're changing it into an angle. To get arctangent changes 4/5 into an angle. But what does the cosine of the arctangent change it back into? What will this answer be? It'll be back to being a ratio. So you take a ratio, change it to an angle, take the angle, change it back to a ratio, is what we're going to do. So just to give you a little bit of visualization of what's happening with those. Now, If you have an inverse in a parentheses, we can, should I sing it? No, okay, I won't sing it. Make a triangle. So make a triangle, yep, do. So we're going to do that because we're going to take this ratio, put it into a triangle. Tangent is opposite over adjacent, so this is going to be the square root of 25 and 16, which is 41. Now take the cosine of that. Adjacent over hypotenuse, and you're done. How many got that? 5 over square root of 41. Good. Did you get that, Luke? What did you have trouble with?
I said not.
Well, what didn't you know how to do? The ratio part? Make the triangle. Does that make sense now? Tangent, opposite over adjacent, and then you finish it? Yeah. Okay, so that brings us to these middle two that you probably ran into in your assignment and you went, forget it, I can't do that. But you can, because what does this do when I have 4/5 and I take arctangent? What does it turn 4/5 into when you say arctangent? Turns it into a what? Ratio into a angle, right? So if this is an angle, this is really saying, what's the cosine of theta? That's what I'm really saying with this one. Now, take a look at this. This one says the sine of the arc cosine of 2/3, arc plus arctangent of 4/3. What is arc cosine 2/3 really changing that 2/3 into? An angle, theta 1. What is the arctangent of 4/3 turning it into? An angle, theta 2. This is boiled down to the sine of theta 1 plus theta 2, which is what? SiCo+CoSi. This is the sum and difference formulas we had before. This is a surprise that this has two angles. Two angles imply you have two triangles. 1, 2. And this will be theta 1, and this will be theta 2. What do you think? Good? So then next thing you want to do is you want to complete these triangles, and eventually what we're going to do is if this is sine theta 1 plus theta 2, this is the sine of theta 1 times a SiCo, that is your SiCo, plus makes plus co and c. And I'll give you these formulas if you need them on the test. Some of you have them memorized, though. It's impressive. Okay, now, cosine is 2/3. So when I look at this triangle, the cosine is adjacent over hypotenuse. So what will this side be? What do you think, Emma? What will that side be if this is 3 and this is 2? Ben will help you if you're struggling. This side is 3 and this side is 2. What will this one be? Yeah, 9 minus 4. Does that make sense? And so that'll be the square root of 5. So about this, we're just going to write ourselves a little reminder. The sine of theta is square root of 5 over 3. This is theta 1. The cosine of theta 1 is 2 over 3. Now let's do this triangle here. Arctangent of 4/3. So for this one, its tangent is opposite over adjacent. So 16 and 9 is 25, square root is 5. That's that familiar 3, 4, 5 triangle. So if I want to know the sine, it's opposite over a hypotenuse. Cosine would be adjacent over hypotenuse. How many got those two? Now the reason I laid these out this way is because now when I take sine theta 1 plus theta 2 and I make this green formula here, all I have to do, that thing. So from here on out, all that you have to do is plug those in. Sine of theta 1, square root of 5 over 3. Cosine of theta 2, that's 3/5. Cosine of theta 1, that's 2/3. And sine of theta 2, 4/5. So that's going to be equal to 3 square root of 5 plus 8 all over 15. Pretty ugly, but that's what it is. Yes?
Just to clarify, is the formula plus the two things together and minus?
Yeah, so for cosine they switch plus to minus, minus to plus. In sine they don't. Yep, thank you. All right, so there you have it. That's your answer for number 2. Now for number 3, arc cosine square 1/3. This is theta. What is the big formula that we have embedded here? It isn't SiCo+CoSi this time. It definitely was SiCo+CoSi here because you had sine theta 1 plus theta 2, right? But here, what do you have? Well, cosine of what? 2 theta. That's the formula we're dealing with there. Does that make sense? That little 2 makes it a little interesting. So this was the cosine squared of theta minus the sine squared of theta. Here's what I'm going to have you do. Now, with this one, I want you to make the triangle, find sine theta, cosine theta, and then plug these in and see what you get.